9-4 common logs. In this lesson, I'm finally going to show you how to evaluate logs using your calculator. So a common log means a log with a base of 10. And because they're really common, we usually write them without the subscript. So if you just see the log of x, what it means is that the base is 10. It's so common that we call these common logs that you don't need to use the base of 10. So log base 10 of x equals the log of x. You can write it like this, it's just fine. If you don't see the base there, you need to assume that it's base 10. The log key on your calculator is for evaluating these common logs that have a base of 10. Okay, so use a calculator to evaluate each expression to 4 decimal places. I want you to find the log key on your graphing calculator and type in log 3. Now this means log base 10 of 3, but you can just type in log 3. And we're rounding to 4 decimal places. When I do that, I get 0.4771. So I want you to try that and see that you get the same thing as me. For part B, I'm going to type in the log of 0.2. When I do that, I get negative 0.6990. Now, this is 10 to that power gives you about 0.2. These are approximations because they're 4 decimal places. Now, if you see a decimal or a fraction, it kind of makes sense that you're going to end up with a negative answer because remember your logs are actually equal to a power. So if you're taking 10 to some power and you get a decimal, chances are that power is negative. Okay, now what if the base isn't 10? Can you still use your graphing calculator? You certainly can. We have what we call the change of base formula. So if you have a base other than 10, this formula converts it into bases of 10. But you need to set up a fraction. So if you've got the log base b of n, you're going to take the log of n over the log of b. So the log of the base goes on the bottom. So if this is our problem, the log base 4 of 12, it's a hard one to solve, but your calculator can do it for you. You can use these common logs. So you would type in the log of 12 over the log of 4. Let's try that with these examples here. So express each log in terms of common logs and then approximate its value to 4 decimal places. So first step, I want you to practice rewriting these. If you're taking the log base 4 of 25, we can use common logs and write, the log of 25 over the log of 4. That's the change of base formula. You don't need to put in a base of 10 because these are common logs. We're going to assume they're base 10. Now, on your graphing calculator, you got to make sure that you type it in. Sorry, guys. You got to make sure that you type it in using parentheses in the appropriate places. So when you calculate this, you should get 2.3. Hold on a second here. You should get 2.3219. So I want you to try that and make sure that you're typing it in correctly. And again, we're rounding to 4 decimal places. So just make sure that you've got that on your calculator when you take the log of 25 over the log of 4. Okay, so part B, we can calculate this using the change of base formula. It's the log of 8 over the log of 6. That base of that little number should go on the bottom. Just remember that. And the log of 8 over the log of 6 should give you 1.1606. Okay, so the beginning of this section is just practice using your calculator. Okay, now the second half of this section is solving exponential equations using logs. The exponential equations, remember, are the ones that had the variable in the exponent. In section 9.1, we had to get like bases on each side of the equation, and then we could set the powers equal. But what if you can't get like bases? Well, then you're going to take the log of each side. Let me show you an example. So what if we're solving 3 to the x equals 11? Well, I definitely cannot get a base of 3 on each side here. So using that trick from lesson 9-1 is not going to work. What you can do is take the log of each side. So you'd write the log of 3 to the power of x equals the log of 11. Now these are common logs with base 10, so you don't need to write any base in there. Now we're going to go back to what we learned at the beginning of the week. Property number 3 from your notes on 9-3. You can take this power and move it out in front. So the log of 3 to the power of x, you can bring that power out in front and write it as x times the log of 3 equals the log of 11. That's using one of the properties that we studied at the beginning of the week. Now, how do you solve this? Well, let's divide each side by the log of 3 to get x by itself and do some calculation. So x equals the log of 11 over the log of 3. Go ahead and type that in. You should get 2.1828, the 4 decimal places again. Let me show you a much harder example, another example of doing this. Okay, so again, if you look at each side here, there's no way I can solve this exponential equation with getting a like base. 4 and 15, there's no hope there. You can't change these into like bases. So we're going to take the log of each side. The log of 4 to the x minus 2 equals the log of 15 to the x. It's just like when you add or subtract the same number on each side, you can take the log of each side and keep your equation balanced. Okay, now using that power rule is kind of what I call it. We can bring these exponents out in front. That property is your friend. Okay, so we need parentheses around x minus 2 here. X minus 2 comes down in front times the log of 4 equals x comes out in front, x times the log of 15. Okay, there's that step. Now is where it gets kind of tricky because I need to figure out what x is, and x is involved with 2 logs here, one on each side. You need to distribute at this point. Okay, so we've got x times log 4, x log 4, minus 2 times log 4, 2 log 4, equals x log 15. Now, these logs really represent numbers here, so we have to treat them as numbers. I need to get x together on the same side of my equal sign. So I'm going to subtract x log 4 on each side next. Those cancel out. Subtract x log 4 on this side. Now I have negative 2 log 4 equals x log 15 minus x log 4. Next step, both of these x's and these logs here, we need to factor them out. I'm trying to figure out what x is here, so I don't want 2 x's, I want just 1. So we're going to factor out an x from each term, bring the x out in front, and then use parentheses. X times log 15 minus, it'd be x times log 4. So we're going to take the x's out in front, and then in parentheses you'd have left over log 15 minus log 4. Now finally, these are being multiplied here, so finally now I can divide both sides by log 15 minus log 4. That's going to cancel out on the right side. This is the calculation that you need to do. Now you want to be careful here. You want to use parentheses appropriately. You're going to need to put parentheses around your denominator because you've got 2 terms here. So x is equal to this side calculated, negative 2 log 4 over log 15 minus log 4. Be careful when you calculate it. I want you to double check that you're typing everything in correctly. Here's what you should get for your answer. Negative 2.0977. And if you're not calculating these right, I'll definitely show you how to do them on the graphing calculator on the smartboard in class tomorrow. Okay, so it is a long process here for these. If you have x on each side of the equal sign, that's when it's going to be a little bit tougher. In example A, we just had x on the left side in the power. So those are pretty simple to solve, but if you've got an x on each side, those get a little bit trickier. I'm going to show you a couple of more examples, but this time with inequalities. So the inequalities, you don't really need to worry about too much here. When you take the log of each side, you'll just keep the same symbol all the way through, unless, of course, you ever multiply or divide both sides by negative. Okay, so same process here. If you cannot get a like base on each side, like 5 and 8, there's no hope there, then you need to take the log of each side. So we're going to take the log of 5 to the power of 3y. That's less than the log of 8 to the power of y minus 1. Now, using property number 3 that we wrote down at the beginning of the week, here's the property, by the way. If you've got the log base b of m to a power, you can bring that power up in front. That's the property that I've been using. Okay, so 3y comes out in front. The power comes out in front. 3y times the log of 5 is less than y minus 1 can come out in front, but you do need parentheses around that one. Y minus 1 times the log of 8. Now the issue we run into again is that you've got the y's on both sides and they're involved with the logs here. This needs to stay together, so I need to distribute y minus 1 times the log of 8. So I'm going to rewrite my inequality as 3y log 5 is less than y times log 8 minus 1 times log 8. That's just log 8. So distribute first to get rid of those parentheses. Now I need to get the y's on the same side of my problem. So I'm going to subtract y log 8 on each side. I'm doing this to get the y's on the same side of the inequality. So now I have 3y log 5 minus y log 8 is less than negative log 8. Okay, now I'm at the point where I'm going to use factoring. I know this is quite a process here. Let me pick a new color. Okay, so using factoring now, I've got a y as a common factor here. Each term has a y, so we're going to bring that out in front, and I'm left with 3 log 5 minus log 8 is less than negative log 8, and then your last step now is to divide each side. If I want to get y by itself, these two are being multiplied, so I'm going to undo that by dividing by 3 log 5 minus log 8 on each side. Okay, again, now you're dividing by more than one term, so you're going to need parentheses around this when you do your calculations. The symbol can stay the same. I haven't done anything here to change the sign, so it's y is less than negative log 8 over 3 log 5 minus log 8. Calculate that, and if you want to calculate it separately, you can calculate it the top first and the bottom second, and then divide. If you want to do it that way, we should end up with here y is less than negative 0.7564. Okay, if you have any questions about this, please make sure that you ask me tomorrow, or if I've got any wrong answers here, let me know. Okay, last part, part B. I actually am calculating these with my cell phone, so I think I'm doing them correctly, but I did verify with the textbook too, so we should be good on these answers. Okay, last part, last one. It's going to be difficult again because notice you've got the variable on both sides of the inequality. So again, you're going to need to do that process of distributing, then getting the x's on the same side, then factoring. It's that whole process. I'm going to show you it one more time. I cannot get like bases on each side, so I'm going to start by taking the log of each side. Now we're going to use that power rule, bring the power out in front of the log on each side. So you'll have a 2x times log of 3 is greater than or equal to x plus 1 in parentheses times the log of 6. Now we need to distribute. So 2x log 3 is greater than or equal to x times the log of 6 plus 1 times the log of 6. Okay, now I've got an x on each side of the equal sign, so let's subtract x log 6 on each side to put the x's on the left. And now we'll rewrite it. 2x log 3 minus x log 6 is greater than or equal to the log of 6. Okay, at this point I'm going to factor out an x here so that I can get just a single x and we can get x by itself. So each term has an x in common. Let's factor out x. You are left with 2 log 3 minus log 6 is greater than or equal to the log of 6. Last step, it's the same last step every single time here, we're going to divide. If I want to get x by itself, I can divide by this entire thing in parentheses. 2 log 3 minus log 6. And divide this side by 2 log 3 minus log 6. These will cancel out on the left, and x is greater than or equal to 4.4190. Notice we're always rounding our answers to 4 decimal places. That's just kind of the general rule here with these logs in all of Chapter 9. If it's not a whole number, if you need to approximate it, round it to 4 decimal places. Okay, I've got a few check for understanding problems here. The first 2 are just practicing with your calculator, and number 3 is solving an equation. Take a look at examples 3 and 4 for that one.